China looked at its driest regions, land where entire river basins had been shrinking for decades, and grain harvests were failing under the country's worst drought since national records began in 1961, and decided the solution was to reach up into the sky and squeeze rain out of clouds that were not giving it up on their own. Not a small pilot program. A weather modification effort that now employs roughly 50,000 people, operates thousands of rocket launchers, and flies dozens of specially equipped aircraft, all dedicated to a single goal: coaxing precipitation out of the atmosphere in the exact places China needs it most. Atmospheric scientists spent decades doubting this was even physically possible outside a laboratory. China built the largest weather modification program on the planet anyway, backed by roughly $2 billion RS in state investment between 2014 and 2021 alone, and now has peer-reviewed field data proving it actually works, along with one deeply embarrassing failed megaproject that shows exactly where the physics still says no. This is the story of how cloud seeding actually functions, what China's own scientists just proved in the middle of one of its driest deserts, and why the same country running this program once tried something so ambitious that atmospheric scientists still laugh uncomfortably when it comes up in conversation. If you have ever wondered whether rainmaking is real science or something closer to a magic trick, drop a comment and tell me which one you assumed before watching this, because the actual answer sits somewhere more interesting than either extreme. I read every one of these. If you are enjoying breakdowns like this, hit like. It takes real digging to separate the peer, reviewed results from the wildest claims, and subscribe so you do not miss the next one. Let us go for 5,000 likes on this one. Now let us get into how you actually make it rain. Before any of the technology makes sense, you need to understand exactly what problem China is trying to solve. Because this program did not appear out of nowhere. China's weather modification effort traces back to the 1960s, but it has expanded dramatically in recent years as water scarcity became a genuine national emergency across several regions simultaneously. The Xiang River Basin, sitting in one of the country's most severely degraded ecological zones, has run cloud seeding operations for roughly 15 years, according to researcher Wei Wang at the College of Aviation Meteorology in Guanghan, and local governments across China have increasingly adopted the same approach specifically to fight water scarcity at a regional level. Xinjiang, the vast arid province in China's northwest, has become one of the program's most active testing grounds, since it combines exactly the conditions that make water scarcity most dangerous: minimal natural rainfall, growing agricultural demand, and a desertification problem that keeps expanding outward year after year. China's State Council announced plans several years ago to expand this entire program fivefold, targeting coverage of roughly 2.1 million square miles, more than half the country's total land area, a scale of atmospheric intervention no other nation on Earth has attempted. Officials have described the ambition explicitly, stating the program is intended to reach a worldwide advanced level by 2035 and to help address not just drought, but hail damage and emergency response to forest and grassland fires, positioning weather modification as a standing tool in the country's broader climate and disaster management strategy, rather than an occasional emergency measure reserved for the worst years. For comparison, the scale of China's investment and ambition here genuinely dwarfs every other national program on the planet. Saudi Arabia, which runs one of the more prominent Middle Eastern cloud seeding efforts, spent roughly $256 million supporting the first year of its regional program. A serious commitment in its own right, but a fraction of what China has poured into its own operations over a comparable stretch of time. More than 50 countries worldwide have experimented with some form of cloud seeding, according to reporting on the practice. Everything from fog dispersal at airports to hail suppression, protecting agricultural regions to, controversially, attempts to manipulate weather conditions around major public events, including the 2008 Beijing Summer Olympics. China is not simply one participant among many in this field. It is functionally the field's largest laboratory, running more simultaneous operations across more terrain than the rest of the world's programs combined. The basic physics behind making it rain sounds almost too simple to actually work. And that simplicity is exactly why atmospheric scientists spent so long treating it with skepticism before the data caught up. A cloud that looks full and heavy does not always release its water as rain, because water droplets inside a cloud often stay too small and too light to overcome air resistance and actually fall to the ground, floating suspended instead of dropping. Cloud seeding introduces tiny particles, most commonly silver iodide, a compound with a crystal structure that closely resembles the structure of natural ice, directly into the cloud. Water vapor and supercooled droplets inside the cloud latch onto those particles, the way frost forms on a cold window, using them as a physical scaffold to begin clumping together. Once enough droplets combine around enough of these seed particles, they grow heavy enough to finally overcome the air holding them aloft, and they fall as rain, or as snow if temperatures are cold enough. Depending on the target, engineers also sometimes use dry ice or various salt compounds instead of silver iodide, since different particle materials trigger slightly different droplet growth mechanisms depending on a cloud's specific temperature and composition, giving meteorologists a small toolkit of seeding agents to match against the particular atmospheric conditions they are working with on any given day, rather than a single universal chemical solution. The delivery method depends entirely on what kind of cloud engineers are targeting and how it is positioned relative to the ground. Aircraft can fly directly into a cloud formation and release particles at altitude. Rockets fired from the ground can punch particles up into fast-moving or higher-altitude cloud systems that aircraft cannot easily reach. Ground-based generators and cannons can release particles that rise on natural air currents into clouds forming above a fixed location. Drones, the newest addition to China's toolkit, offer something the older methods struggle with: precise, repeatable targeting of a specific cloud at a specific moment, without the cost or risk of putting a piloted aircraft directly into unpredictable weather. A drone can also loiter and adjust its position as a target cloud shifts, something a rocket, fired once toward a fixed point in the sky, simply cannot do, and something that makes a meaningful difference when the cloud being targeted is moving faster or less predictably than forecasters expected at the moment of launch. Even identifying which clouds are worth seeding in the first place is its own technical discipline, one that happens well before a single rocket fires or a single drone takes off. Meteorologists analyze radar returns and satellite data to identify clouds already, carrying meaningful supercooled liquid water, essentially water that remains in liquid form even below freezing temperature, because those are the clouds physically primed to respond to seeding. A cloud with too little moisture, or one already too warm and too far along in its natural precipitation cycle, offers almost nothing for seeding to work with, no matter how much silver iodide gets introduced into it. Choosing the wrong cloud is the equivalent of trying to light kindling that never had enough dry wood in it to begin with. The spark alone changes nothing if the underlying material was never going to catch. The clearest, most rigorously documented proof of how well this actually works came out of Xinjiang in a field experiment led by the China Meteorological Administration's key laboratory of cloud precipitation physics, and weather modification in Beijing, working directly with Xinjiang's own weather modification office. A fleet of drones dispersed silver iodide powder into target clouds over a single day, covering more than 3,000 square miles of the region's driest terrain. The amount of material required to pull this off is almost comically small next to the results it produced. Just 2.2 pounds of silver iodide powder, a compound roughly 6 times denser than water and small enough in total volume to fit inside a single travel mug, generated more than 18.5 million gallons of additional precipitation, enough water to fill 30 Olympic-sized swimming pools, each 6.5 feet deep. Across the targeted region, that translated to a measured rainfall increase of just over 4% in a single day. And the research team did not simply take the figure on faith. They cross-checked it using 3 separate validation methods. Direct raindrop measurements showed droplet sizes growing from roughly 0.46 millimeters before seeding up to 3.2 millimeters afterward, a jump large enough to be the physical difference between a droplet floating, suspended in a cloud, and one heavy enough to actually fall. Satellite imagery independently confirmed the same event from above, recording cloud top cooling of up to 50 degrees Fahrenheit and physical cloud growth of nearly 2 miles following the seeding operation. Both signatures consistent with the seeding process actively working, rather than the rainfall being coincidental. The full results were published as a peer-reviewed paper in the Chinese language journal Desert and Oasis Meteorology on April the 10th, giving outside scientists an actual data set to scrutinize rather than a press release to simply take at face value. That kind of rigor matters enormously in a field this easy to oversell, and the researchers behind the Xinjiang study were notably direct about what their own results did and did not prove, an honesty that stands in sharp contrast to how weather modification is often portrayed in casual news coverage, where a single successful test can get stretched into a much broader claim about drought relief on demand. They raised, in their own published paper, genuinely difficult open questions their experiment could not fully answer, including how to definitively distinguish a case where seeding amplified natural precipitation from a case where it may have inadvertently suppressed rainfall that would have fallen anyway. What specific metrics should even be used to calculate water gained versus water that might have been lost in the process? And how a single day's measured benefit might or might not scale up across an entire season or year of repeated operations. Jeff French, head of atmospheric science at the University of Wyoming and not involved in the Xinjiang study, put the honest scientific consensus plainly when asked about cloud seeding broadly, saying that from a physical standpoint, he could say very confidently that cloud seeding works. But he was equally direct about where that confidence ends, cautioning that if the promise being sold is that cloud seeding will eliminate droughts, even at a local level, the answer is no, and that the underlying theory behind that stronger claim simply lacks scientific evidence. The long-term picture from the Xiang River Basin gives the clearest sense of what disciplined, sustained cloud seeding can actually accomplish once it moves past a single day's experiment and becomes a genuine multi-year regional strategy. A study published in the journal Atmosphere found that rainfall in the basin increased more than 20% since operations began roughly 15 years ago, and researchers documented a clear, measurable reversal in vegetation health trends, tracking closely with that increase. Areas of low and moderately low plant coverage shrinking, while moderate to high coverage areas expanded across the same period. Wei Wang described the Xiang Basin as one of the regions most severely affected by ecological degradation anywhere in China before this program began, which makes the documented vegetation recovery a meaningfully different kind of evidence than a single dramatic rainfall event, a slow, compounding ecological shift that only becomes visible after years of consistent intervention rather than one headline-grabbing test. It would be dishonest to tell this story without also explaining the one part of China's weather modification history that the country's own scientists now treat as a genuine embarrassment because it shows exactly where this technology's real limits sit. Around a decade ago, China proposed an enormously ambitious project nicknamed the River in the Sky, aiming to seed clouds across a stretch of the Tibetan Plateau covering roughly 620,000 square miles, an area comparable in size to the entire state of Alaska. The goal was staggering in scope, diverting moisture from the Indian monsoon as it moved across the plateau, redirecting it away from the all-red wetter Yangtze River Basin, and channeling that redirected water instead toward the dry yellow River Basin further north. Sang Ye, an atmospheric scientist who has studied this specific history, described how researchers outside the project now react to it, saying that when you go to China and ask atmospheric scientists not directly involved on the project about it, they simply laugh, treating it as an awkward, embarrassing episode nobody wants to revisit in detail. That reaction from scientists inside China's own research community carries more weight than outside criticism ever could, since these are people who understand exactly how difficult large-scale atmospheric intervention genuinely is, and who watch colleagues attempt something the underlying physics was never going to support at that scale. The reason it collapsed comes down to a basic physical limit. Cloud seeding cannot talk its way around. You cannot convert the entirety of the moisture moving through the atmosphere into rainfall, and you cannot meaningfully channel that moisture along a chosen path across hundreds of thousands of square miles the way you can direct water through a physical pipe or canal. Cloud seeding can nudge an existing cloud that is already close to releasing its water. It cannot reroute the sky. By 2022, researchers had quietly scaled the project down dramatically, and China's newest 5-year plan, covering 2026 through 2030, mentions expanded weather modification broadly, without referencing this specific project by name at all, which independent observers have taken as a strong signal the original river in the sky concept has been abandoned in everything but official acknowledgement. That contrast, a small, tightly targeted, rigorously measured drone operation over Xinjiang actually working, against an almost continent-scale atmospheric engineering scheme that quietly failed, tells you almost everything about where this technology genuinely succeeds and where the physics simply says no. Cloud seeding is not rain from nothing. It is a targeted nudge applied to a cloud system that already has real moisture inside it, waiting on the physical trigger to actually fall. And the closer the ambition stays to that honest description, one region, one weather system, one clearly measurable operation at a time, the more consistently the field data backs it up. The practical stakes behind getting this right extend well past a single drought season, and they extend past China's own borders too, since several of its neighbors share the same river systems this program is actively trying to influence. In 2022, facing the driest summer China had recorded since 1961, the government turned specifically to cloud seeding in an attempt to save grain harvests that were failing across multiple provinces, simultaneously deploying aircraft and rockets to try to trigger rainfall over crop-growing regions before the damage became irreversible. Reservoirs along stretches of the Yangtze had visibly dried in sections, and officials described some seeding operations as sitting on standby specifically because cloud cover in the target area was, in their own words, simply too thin to seed effectively, a detail worth stating clearly. Because it undercuts any narrative where this technology can simply manufacture rain regardless of existing atmospheric condition S. Cloud seeding needs a cloud with real moisture in it to begin with. Without one, no amount of silver, iodide, rockets, or drones changes anything. A limitation. The technology cannot engineer its way around, no matter how much funding or manpower gets thrown at the problem. Behind every statistic in this story is a version of daily life directly shaped by whether these operations succeed or fail. It is a farmer in a province depending on a delayed monsoon watching aircraft pass overhead, hoping the seeding operation working that cloud system translates into water, reaching fields before harvest is lost entirely. It is a researcher in the Xiang Basin measuring vegetation coverage year over year, watching a slow, patient, ecological recovery that only becomes visible on a time scale of over a decade, rather than a single dramatic before and after photo. It is a village that depends on that same basin's water table for both drinking supply and irrigation, watching 2 decades of shrinking coverage slowly begin to reverse rather than continue its previous decline. It is the 50,000 people working across China's weather modification program, monitoring radar for exactly the right cloud formation at exactly the right altitude with exactly the right moisture content, because success in this field depends less on brute atmospheric force and far more on recognizing the narrow arc specific conditions under which the physics actually cooperates. So what does all of this actually mean, whether you live somewhere already experimenting with cloud seeding or are encountering the concept here for the first time? It means the core technology is real, measurable, and increasingly well documented by peer-reviewed field data, not a fringe pseudoscience or a magic trick. But it also has a hard, physically grounded ceiling that no amount of investment or ambition has managed to raise. You can coax more rain out of a cloud that is already close to producing it, and you cannot summon water from a genuinely dry sky or redirect entire moisture systems across a continent the way water moves through a canal. Understanding that distinction is exactly what separates the legitimate, functioning parts of China's program, the Xinjiang drone trials and the Xiang Basin's documented recovery, from the parts that quietly failed and now draw uncomfortable laughter from the country's own scientists. The honest, grounded summary of this story is this: China operates the largest weather modification program on Earth, backed by roughly $2 billion in state investment between 2014 and 2021, and employing an estimated 50,000 people across rockets, aircraft, ground generators, and drones, with an announced ambition to reach a worldwide advanced level of capability by 2035. A rigorously validated 2025 field experiment in Xinjiang, led by the China Meteorological Administration and published in the peer-reviewed journal Desert and Oasis Meteorology, showed that just over 2 pounds of silver iodide powder generated more than 18 million gallons of additional rainfall across a single day, confirmed independently through raindrop measurements and satellite imagery. Longer-term results from the Xiang River Basin show a documented 20% rainfall increase and measurable vegetation recovery sustained across roughly 15 years of continuous operation. Set against those genuine successes is the River in the Sky project, an attempt to redirect monsoon moisture across an area the size of Alaska that collapsed under the basic physical reality that atmospheric moisture cannot be channeled like water through a canal. A failure the country's own atmospheric scientists now treat as an open embarrassment rather than a footnote. Cloud seeding works. It does not, and physically cannot, eliminate drought on demand. We are going to keep tracking developments like this exactly the way we tracked it today, straight from the peer-reviewed studies and the scientists who actually ran these experiments, not press releases stretched past what the data supports. Subscribe so you do not miss it when the next round of results from this program gets published, because based on how active this research area has been, it will not take long. And leave that comment below. Tell me honestly before this video, did you think cloud seeding was proven science or an unproven gimmick? Because the real answer, working reliably in narrow, specific, well-measured conditions and failing outright at continental scale, sits somewhere neither assumption fully captures. 5,000 likes on this one. Let us go. See you in the next one.